Brad?
Want me right here?
Yep. No, we're not starting yet.
We're not started yet. We are getting ready for the movie. Please.
You want me here?
Yeah, you can
Thank
sit
you,
there.
sir.
You can sit there. Yes. Yes.
You, me,
Yeah. Okay.
whatever. Last time
And Kevin, can I have water,
Yeah,
please?
no kidding.
Thank you.
Everybody have a water?
Yeah.
I like them better.
They have 2 there. Down to Max.
Here you go, Maximilian.
Clicker 2.
No, clicker goes to Brad.
Do we not have the images?
Well, they need to start the. Yeah. Yeah, yeah.
So, my wife Patricia is here as well. So she's waving it this way.
Where is she? That's her. Oh, you'll have to introduce me afterwards.
No video. Oh, thank you.
okay.
All right.
We'll be our
Thank
own
you.
video then.
Okay, we'll do our own video, Kevin. Well, thank you, everybody. I'm Helena Lisachuk with Deloitte. I'm here together with Kevin.
Hi, Calvin Smith from Wipro. Pleasure to have you all here today.
And we're here to talk about the digital twin. Both Kevin and I, we are part of the program committee for this lovely event, and great to see you all in Barcelona. And we thought it would be very important in the world of industrial IoT to talk about one of the fundamental components, such as digital twin. We are joined today by a set of our experts. So we have Brad Surak with Hitachi, Maximilian Schroeck with Deloitte, and
Hanspeter Meindl with Wipro, and of course Mark Gallant from PTC.
And we are going to talk about how to get started with a digital twin and why you would want to create one. You could actually think and envision about so many things that require a high degree of accuracy. And when you build, let's say, a model for a customized car, or maybe a robot that needs to repair a nuclear reactor, you want to make sure whatever you put in a model acts exactly the same in a physical world, and it's possible with IoT. One of the fundamental enablers is a digital twin. So Kevin, what is the definition of the digital twin?
Well, realistically, it's all about managing performance, right? I mean, we're at an IoT conference. We talk about the tremendous volumes of assets that are out in the field. And most people, when they think of a digital twin, think of an individual product. But there's actually a hierarchy, right? You can move from a product to a fleet of products to essentially to a process, even looking at your entire business itself and or a facility and looking at mapping out a digital twin of that. But you're not here to hear from me today. Let's hear from our expert panelists and really dig deep on what is a digital twin.
Yes, absolutely. So let's go to our experts. Brad, representing Hitachi, could you please tell us a little bit, what is your view about digital twin? What is your experience? Why is it relevant? Please.
Sure. So I thought maybe the best way is to show some examples of digital twin, as there's no single definition of a twin. So let's see here. If I can get the next slide, please.
Yep, you got it.
Oh, it's up.
Keep one more.
Oh.
Do we have the...
Okay, there we go.
Okay.
So,
Yes.
so this is one example of a digital twin. What you're looking at here is a robot that Hitachi has created to help with the cleanup of the Fukushima reactor. And so you're asking, why is this a digital twin? Well, as you can imagine, it's a pretty dynamic environment that this robot had to operate in. And so the first robot that we deployed actually got stuck inside of the reactor. And so what we ended up doing was creating a physical twin of the reactor itself, and then using that twin to train the robot to navigate through the spaces, deal with some of the dynamic situations that it finds inside, and eventually get in and make the necessary measurements. So at one level, this is an example of actually a digital twin of the reactor that actually was used to train the robot on how to navigate in that space. Next slide, please. Click it. So here's another example of a digital twin in one of our factories. This is actually an automotive factory. I believe it's in China. It's a twin that combines multiple types of data. So it's using video data. Clearly, you can see the video there. It's using some LiDAR data on the machine. It's also using sensor data. So it starts to use the sensor data on the machine to identify conditions where the machine is starting to have an anomaly. It then directs the repair crew to the machine and the problem, the diagnosis of what that problem is. So this is just another example of a digital twin where we've actually twinned the factory manufacturing line as well as the assets. So we've got a hierarchy of models here, one model for, a model for the particular machine and the physics of the machine that can be used to detect the problem and diagnose the problem, and then the factory floor model as well, and then guide the technicians to the problem spot and eventually through the repair as well. On the next slide, we've got there it is. And I think I have to click one more time for the video to get started here. Now, at Hitachi, we operate a large portion of the rail network in Tokyo as well as in the UK and some other major metropolitan areas. And as such, we have to operate the terminals. This is actually a video. There it goes. So we operate the train stations as well. What you're seeing here is, again, a digital twin of the station. And what we've done is we've taken the raw video data on the left as well as the LiDAR data on the bottom left-hand corner. We've anonymized the people because we don't want, it's not about identifying the people. We protect the identities of the people in the station. What we're interested in is the direction of travel, the velocity of travel, the congestion in the station. And we use this from an analytical standpoint to understand the flow of people through the station. We can do things such as interfacing back into escalators and different people movers in the station when it's really crowded. The escalators, for example, will all start flowing up to help the people empty the station. And so it's an adaptive sort of model in the station to help manage the flow of traffic, but it's based on a combination of sensors, LiDAR and video in this example, and semantic search on that type of data. That's another example of a digital twin. Let's see, next slide. And, I think the last piece, and this is another video here, click to play. So this is that same data. I was showing you the raw data of the digital twin model. I think really where, the challenges are today in many industrial settings is how do you scale these twins out, and how do you make it easy to take the analysis that comes off of them and allow your average IT developer to develop an app around it. So this is an example of an app. The app is actually for someone who manages a train station in Tokyo. It was developed on top of a platform, an IoT platform called Lumada that makes it very simple for a developer to take the complex sensor data, integrate it together, do the analysis required. But then really you don't need to understand any of that to make the app work and put it into the hands of the people that actually need it. So I thought that would be a good sample of different kinds of twins that are in production today.
Thank you, Brad. That's definitely very impressive. And there is a clear value that every twin creates, and there is a very specific business question that's being answered by each of the twins examples. But how do you, if you start thinking about implementing them, you kind of need to, you mentioned the user, right? You mentioned the technology, you mentioned IT and IT. Feels a little bit like a transformation, right?
Yeah, very much.
So may I ask you and Maximilian to elaborate a little bit on the transformational nature of taking one of those twins?
Sorry, they're writing messages to us.
Apparently I'm clicking the wrong
Thank you.
Appreciate it. Whoever's writing us the messages, we appreciate the guidance. We see something you don't. I wish we could I wish we could create a twin of this. If you could put that up on the screen, that would be hilarious.
Transfer.
So thanks, Helena. I'd like to answer your question in two ways. So the ultimate purpose of the digital twin is to create business outcomes, to enable business outcomes. And I want to focus on two things. One, to enable outcomes with existing product services within and the established value chain, and I also want to talk briefly about the digital twin enabling new products and new services within new emerging ecosystems. So on the former, the proliferation of compute, storage, sensors has allowed something which has actually been around for many, many decades to become richer, more open, more contextual, and provide a data set which allows actuation at a much broader level than ever before. However, to drive to the business outcome, it should be obvious that processes need to be affected, behaviors need to be affected, organizational structures may have to change in order to bring about the type of business outcome that the enterprise desires. So it really becomes a change management effort that wraps around the digital twin as a core enabler. On the second topic, the digital twin as a part of new solution offerings really enables new avenues to revenue for enterprises, either through services or new solution stacks, and allow for monetization of data and insight in completely new forms. The implication of that is equally transformational for the enterprise, because the enterprise will typically provision these new solutions and services on a consumption basis, and you need to build the business system underneath these type of offerings to bring about the business outcomes there, new revenues, new services, and so forth. So that's how I would answer your question.
Okay, thank you.
Yeah, excellent. Yeah, so kind of taking a step in a slightly different direction. Hanspeter, I mean, having been in an exec in the past at Siemens and Dassault and some of the companies that are working in this area, certainly worked at a handful of factories themselves, a number of startups, and now being at Wipro leading smart manufacturing globally. I mean, it all sounds great. Clearly, we want to work towards some KPIs. We want to derive some business value. But how do I get started, especially in a manufacturing context? And tell us a little bit about, what are some of the use cases you've seen over the years?
Sorry. Let me start with a very simplistic statement. If you look at factories and if you look at brownfield environments, you don't start today. You probably started decades back.
Yeah.
We did not call that a digital twin, we called it a model. So if I start going back in time, thinking about my time in managing semiconductor lines, we built a model of that line to plan and track production through that line, to know what is going on.
Yeah.
So we had a digital representation of what was happening on the shop floor. Maybe it was not a complete model of the shop floor. It did not cover all the services and everything that happened, but it served the purpose to give us the information what would be coming out of the line with a high probability at a given point in time. So if you compare that to the definition that you just made, Calvin, I think we're pretty much spot on.
We're well aligned. Excellent. Very glad to hear.
So I think if you look at brownfield environments and also upcoming greenfield environments, a lot of the modeling has already been done.
Right.
It's getting more and more.
Right.
You want to drive more value out of that. You want to get leaner, more efficient on the shop floor, which means you need a more elaborate model. Now we're in the state that we can get to build that model because now we have the technology.
Excellent. Oh, please, want to jump in? Yeah.
If I can jump in, I entirely agree here. What we see, though, also is that our product definition changes, right?
Yeah.
And so products today are collaborations of multiple parties, and as a consequence, the digital twin concept, extends to modeling outcomes of syndicated collaboration. And so I think it's important, I completely agree, you need to bring in, integrate, contextualize the various models, but I think one should also be clear that, say, if you deploy a complete solution stack against a use case such as predictive maintenance, for instance, right, you will have multiple collaborators, contributors to that solution, all of which will produce outcomes which have to load on the ultimate outcome.
Yeah, well stated, well stated. And Mark, certainly, I mean, you've got a number of years in manufacturing yourself,
Yep.
on and off the line, from the factory and to the field, and now running a broad swath of products over at PTC, which has one of the most really holistic offering sets from edge to core to cloud in the space. Tell us a little bit about, how would you pragmatically get started from day one, right?
Great question, and we get that question frequently. Now, PTC is certainly at the middle of the physical and digital convergence. We've got design tools and PLM tools on one end, and then IoT, Industrial Innovation Platform, on the other. And those together bring the digital and physical together. So where to start? It really depends on your business. First and foremost, echoing several of the themes here, it's about your business and how you can improve your business and your operation. So if I'm making high complexity products at lower volume, I may certainly start with the product as a digital twin. If I'm making a lower complexity product at very high volume, maybe a stamped automotive component, I'm going to start with the machines and the process. So my digital twin is going to start there. I've been very fortunate to tour hundreds and hundreds of factories around the world. I'll give you a couple of examples on where to start. So we went and toured a plant. I was touring a plant with the plant manager. And by the way, plant managers inherently know if you ask them what are the top 3 machines that they need to keep running and are the most important to their factory, they will always tell you. So don't be afraid to ask. And those of you in manufacturing are smiling. I see some smiles. You know which pieces of machine are the most critical to your operation. So I'm touring a factory with a plant manager, and he says, yeah, this is the most important machine, and we're talking to the operator, and the operator, Julie, is talking to us, and she goes, hang on a minute. She runs over, and she turns a couple of things and comes back, and the plant manager was looking at her, and she goes, it just didn't sound right. She knew inherently from using that machine for 30 years that it just didn't feel right. She over and adjusted it. So they added some sensors to those machines. They had some sensors on it, but they added a few more sensors to those machines. And the goal was to reduce the parts per million defective on this line from about 1,600. They wanted to get 20% improvement, which 20% improvement in quality in manufacturing, that's a challenge.
Yeah.
Censored the line, 45 days later, start pulling the data and create their digital twin. A few months later, they had gotten their PPM down to 800. So 50% improvement. Great success, that's where they started. They went back to the equipment manufacturer who had the actual designs and said, what is the theoretical PPM that we should be running? They came up with roughly about 400 PPM that they should be doing. They said, oh shoot, we're at 800. We thought that was phenomenal. We're going to get to 400. Right now they're running about 453. So they're almost at the theoretical. So that's one example of where to start. So it really depends on your business, what is going to drive the most value in your organization, and where your journey are. Many of you may be at one end of the spectrum just starting. Some of you are well along the way, and the team here, and the other thing I want to point out, this is a team sport. Going forward, digital transformation is a team sport. That's why we have different members of the team here, and I'm very proud to be part of that.
Thank you.
So thank you.
Thank you so much.
Thank you. Thank you for giving us a pragmatic, inspirational, and also kind of realistic journey example. But what are some of the key considerations in terms of when you start building, right? Let's say you started the journey. What are some of the most important considerations? Is security important? Is interoperability? Is data structures? Brad, do you want to comment a little bit on that?
Yeah, I think, the practical considerations, well, first, to echo Mark's point, you start with where the models you already have. These models don't have to be brand new models. Most companies have modeled their operations to some degree, have modeled their assets, and so you start with those assets. I think the challenge comes when you start to scale that out to an enterprise-wide implementation. We've all, probably been through a lot of IoT POCs that never really get to scale, and so the keys there are security, being able to secure the data transmission between the twins at scale, and especially if those twins are actuating a piece of equipment, that becomes super critical. I think also what we find is just the management of that data in this distributed architecture that brings in edge data, mixes it oftentimes with contextual data from your ERP or from your production systems, and goes out to the cloud. That's also a challenge.
The machines agree. Hanspeter, the twins are agreeing.
Yes.
Something you'd like to add, Hanspeter?
Yeah, if you look at that, why do you build a digital model so that you can mirror your physical environment, that you get into a closed loop, which will require a lot more integration with the shop floor. This is posing security threats, because all of a sudden you're integrating your operational network with your IT network.
Yeah.
And unfortunately, all the measures, the security measures that you use in your IT network don't work on the operational side. So you have to build something completely new. You have to start thinking differently. The next thing is how do you normalize all the data? Because you will get a lot of information that is potentially the same, but it will look differently. So how do you get that in a form that you can really start using this in analytics?
Yeah.
And that brings up the third topic. We had that on Monday. How do you ensure that the database or the data lake that you're filling is filled correctly with high quality data in a consistent way?
Right.
You're basing your company, your decisions on that data.
Yeah, excellent point, excellent point. Anything to add, Maximilian?
No, I think excellent comment. I think about the challenge really at three levels. One, I think there's a challenge around multi-standard data ingestion, right? Correlation, cleaning, calibration. So first order, and I think I'm echoing your point. I think the second thing I think about is that the integration with the existing system environment. You cannot actuate unless you're integrated into your MES, manufacturing execution systems, ERP systems, and all the ancillary systems around that. And maybe just as a provocation, digital twin to me goes beyond the shop floor today, and I think has to as a concept.
Right.
And so to the topic of security, as we think about the digital twin relating to entire solutions or processes, right? The intrusion points from a cyber perspective become they proliferate, right? And so the security wrapper around these solutions goes way beyond, right? Kind of emulating closed system solutions that you have on our shop floor, SCADA systems and so forth. It really requires multiple layers of wrappers, and may go all the way to the way in which you train the sensors to communicate to one another, to ingest data and so forth. So these are the three layers, I would think.
Yeah, if we can pick up on that, actually, you touched on a really interesting point, and let's reflect on the title of the session again. We have a couple of kind of loaded terms in there, right? And you mentioned closed loop, and you kind of mentioned factory to field, right? What are some of the use cases we can enable? Let's think about over-the-air updates in one direction, and then influencing product roadmaps in the other, right? So what is it that digital twin or digital thread can do that's different than what we've been talking about all week around IoT generally? Anyone want to pick up on that? Perhaps Brad, Mark?
If you talk about closed loop, then this is actually about getting feedback from real life, from the physical world, back into digital to control my assumptions, my models, and hopefully improve them over time.
Right.
Yeah.
Right.
So that's the key consideration. And one point I would like to add is also, whatever we do, we have to build that in a way that it is able to consume change in technology. I cannot tell you what new technology will come around the corner tomorrow. The only thing I know, there will be something new.
Yeah. Yeah, and I think, we talked a bit about the data management challenge. It's really about managing all these twin models at scale. That's the hard part about this. And if you're trying to get a digital thread that links these models across your value chain, you'll find maybe a maintenance application that will understand that a piece of equipment is failing and direct someone to go address it. But then way back in the design cycle, when it's being modeled in the PLM system, you can go back and look, and was the design the problem? Was the problem in manufacturing? Some of the video I showed you there can identify if it was actually a defect caused by the person who was doing the manufacturing, or maybe the machine that was doing the manufacturing. So it's correlating all of these models is where real value can be unlocked.
Exactly.
But that's really a data management problem, and you really need a way to manage this distributed data from edge to cloud to make all that work. It's not an easy feat to pull off.
Couldn't agree more, couldn't agree more.
So I think there's a couple of other aspects. Having smart connected products in the field changes the way you interact with your customers like never before.
That's right.
And that influences design, but not just design, but how you support your customers. You may now put a product out in the field and you spent millions of dollars designing this little button, only to find out that 0.02% ever pushed that button. And so as you change your design, it changes how you operate, but it also changes how you experience and share customer satisfaction with your customers, right? You now see how they're using the machines and how they're not using it. Are they using it 4 hours a day or 20 hours a day. It changes how you can react and support your customers in a totally different way, and then bring all that data in real time back to your engineering teams. And the engineering teams now get great insights like never before. Because a lot of times engineering only hears from the customer when it's broken. It's broken, it doesn't work, they get on the phone, they call tech support, they're screaming. Now with smart connected products, you get real-time data on how they're using it in a very different way. So I think we need to do that. Now back to the factory for a second.
Please.
A couple of things is have a vision of the future with your digital twin. But I will say, don't be afraid to change. That vision needs to be adaptable. And it's okay to fail once in a while. If you're not failing and pushing the envelope, and some of our customers say, you don't know until you get going, but get going, and then you're going to find out, you're going to learn. So you don't know until you go. So it's okay to fail once in a while, and it's okay to change your vision and have your vision be a little adaptable.
Rapid iteration, agile thinking, absolutely. And beyond silos, right? I mean, getting outside of just the one person.
Yeah, Maximilian.
Yeah, if I can just once again move towards the bleeding edge a little bit here. So if your question was, you know, how can you use the digital thread? So Brad started to talk about that. I think the digital thread, you know, holds the promise of collaboration, syndication, ecosystem formation towards new solutions. It's a shared data kernel that ultimately is being developed. A digital thread can also be fed by information that comes from fleets of equipment, which I think is one of the holy grails, such that you can actually not just derive information from your own asset or set of assets, but it's really across entire fleets, which is relevant to not only fleet operators. And then ultimately, as I said earlier, the digital thread enables new services and offerings as well, because you can package insight. And I give just one example to the underlying changes within the business that have to occur. Brad and I collaborated extensively over the years, and you know, so one of the areas that sees massive change is contracting. Right, so do you own the asset, or does your customer own the asset? If you own the asset, then obviously the digital thread of the information is critical in the way you structure service contracts, right? How you mitigate for risk, how you basically create the actuarial models, right, that determine whether you're profitable or not. So there's massive change in that environment, just as one example.
Let's move up that continuum, that spectrum, right? Because you're going from product to process. The train example was phenomenal earlier. We have a customer, a very large retailer, where we're actually creating a simulation, right? A digital twin of a distribution center, right? So that they can actually make more agile, much more rapid changes and do it in the software world where it doesn't cost quite as much, as opposed to in the physical world where you need to build out a new center and new processes every time. So let's start talking about, you know, different types of twins, right? If it's not only a product, what does that mean? And how do you do that at an enterprise level? Any thoughts, Brad?
Yeah, I mean, well, I think, you know, if you think about the twins, they're really a hierarchy of them. You can do it at the asset level, you do it at the plant level or the store level, the facility level, and you look at it from a system perspective. So when the rail example is a good one, because you model an individual rail car or even a sub-assembly on a rail car. Then you look at, you know, the station. We talked about the station, but there's many stations. They're networked together. So then you look at optimizing that network, that rail network, and the flow of many different assets across that network.
It becomes a system of systems.
A system of systems.
Right.
And really what this all boils down to, if you have a model at that level, you now have new business model opportunities that are derived from the data that you're receiving. You have more insights, and you can monetize that data. You know, an elevator operator could potentially take that digital twin, and this is a real world example. They take that and then they sell it back to shopping mall operators, because then they can charge more for the rents depending on how many people flow, and they can optimize the flow of people through the shopping mall. So that's a brand new digital, you know, product line for that elevator manufacturer that they didn't have before. So that takes a huge transformation, you know, to be able to do all of that and sell it as a service.
Absolutely. So we started talking a little bit about the future, the twins of twins, right? So what is the next generation of the digital twins? What are maybe some of the new technologies that are evolving and are growing quite rapidly? Can you give us some examples? Look into the future and tell us what could be different.
Yeah, this is one example that we have working in a lab right now that we think that we're pretty excited about. It's just really getting the intelligence of the twin, the analytics, and interfacing it with the control system to do the actuation. So this is a complicated slide, it's a research slide, but the way to think about this is there's a piece of equipment that rolls a piece of metal through it, and it has to have very precise sort of parameters by which it rolls that metal. What we've done is put deep learning into the control system, linked it back with the digital twin on the piece of equipment, and now what the control system can do is adapt to not just the wear of the machine, and as the machine wears, it changes the control inputs to maintain the quality of the output. It also adapts to the operator. And as different operators come and set the machine at different settings, the quality varies. And so as we have an aging workforce and in manufacturing facilities and in industrial operations, having control systems that can adapt to and learn from the operators and optimize from that, that's really where we see this technology going in the future.
That's excellent. I'd love to, if we could just pause for a second, come back to this notion of product to service transformation as well. If anyone has, anyone on the panel, if you have any other examples, right? I mean, I think, again, one great use case that digital twin does enable is as you have more and more data, and you know more and more about your product and your fleet of products, or be it your enterprise, or be it a factory itself, you're able to run better and better simulations and refine your models, right? Especially with neural nets and deep learning applications. And then you can really start to sell things on an OpEx basis as opposed to CapEx. So what does that mean? What are some other examples of places you've seen this working particularly well in terms of product to service transformation?
If you look into the aerospace industry, especially the engine part, you can hardly buy an aircraft engine any longer.
Yeah. Yeah.
No one's going to sell the engine. They sell you the usage of, you pay for the usage of the engine. You can see that with some large truck manufacturers. So they don't sell you the truck, they sell you the operation hours. So this is, and you can do that more and more because you get more and more information about the actual behavior, actual usage of the object or the product that you're selling. So you're in control. In the past, it was based on assumptions, and you were never able to verify those assumptions in real life. Right. Are they really doing what they told us they would be doing? Right. And we had that discussion, I think, around JCB, where you can say, okay, this is only supposed to work in a certain area under certain conditions.
Yeah.
And you can monitor that. If it moves out, you get a notification. You immediately know someone's mishandling, mistreating, breaching the contract.
Makes total sense. And you were speaking of contracts earlier. Please, Maximilian.
Yeah, just
absolutely.
As a general trend, what we see and what we see validated through the surveys we drive is that a general push towards customers wanting to consume rather than purchase. So it's classic CapEx to OpEx. So pervasive trend driven by a variety of factors that I'm not going to discuss here, but just as an example, we're actually collaborating with Brad in defining effectively the progression to whole offers, to whole solutions. And these solutions will ultimately treat the present CapEx product as an asset to the solution, but there's a number of different wrappers around it. The digital twin is one of them, which ultimately enables fully managed environments to be provided and to be provisioned, right? So smart data center is one example, right, where you take what is presently a CapEx business and you overlay it with intelligence, experience, and ultimately derive a product from it, which you can provision across a broad inventory of data center as a service.
Yeah.
Okay.
I mean, I think as you can see, it's this broad spectrum from getting started with where you're at. You know, you've got a model, got some sensors, and you can start to do some good stuff with it. And it leads all the way towards digital transformation, where you're taking these systems of models, finding new ways to monetize that data, and that changes the whole operating model of your company in order to take those to market and monetize it. So it's this really, I think, rich, interesting area to explore to drive growth for your business.
Absolutely, and this is all possible today, right? But let's say 5G is available, everybody can be on 5G. What would your digital twin look like then? Maximilian? Ken?
Yeah, so I think as a general matter, I think the digital twin as a core element to solution offerings, right, will continue to evolve in a variety of different ways. Architecturally, right, it will also evolve by the sheer availability of bandwidth within the factory, because it determines as to the type of data standards, the data volumes that you can ingest. The twin will evolve with the type of architectures that will be built from edge to cloud, right? And the way information and insight is going to be managed through that. So I see a general evolution here. So 5G for me is not like a single topic. I think it's going to be one of the factors which is going to drive further proliferation of the digital twin in its capacity to actuate and improve performance.
Let's talk about other enabling technologies.
So I
Mark.
think there's another one coming on the horizon. We've talked a lot about the physical and the digital. That's a lot of information. How do we connect it back to the human side? So augmented reality is a very immersive way of sharing the digital information back to the humans, and we can't forget the human element. This whole digital transformation changes jobs. It changes people's careers. It changes how people work. So we always need to think about the human, but I do think augmented reality is definitely going to be changing in the future, and how we interact with these digital twins.
I think that's a great point, and I think that's where this technology, where the operator and the control system can learn from each other. The control system can learn from the best operators.
Yep.
Make the average operator as good as the best operator by offering suggestions. Because what we're not seeing right as we roll this technology out is giving complete autonomous operating control to the control system to make these changes. You still have a person
They'll
in the
have
loop,
a person
but
involved.
you can use it to train that person to be more
We've
effective.
seen examples of improvement in operation efficiencies, 30, 40% quicker learning, better quality through immersive augmented reality experiences. And of course, you can see them in the booth at PTC. I got to put a little.
You got to put the plug. We're not going to argue with
Very
that.
good point, thank you. And let's not forget the people, right?
That's right.
Can't
Yes,
forget
yes,
the
yes.
people. It's the humans.
Yes,
And Hanspeter,
Hanspeter.
any wrapping thoughts?
Just
Yeah.
adding on top of that,
Yeah.
if you look at the highly developed countries like in Europe, like in the US,
Yeah.
you also need that to maintain your operation.
Yeah.
Because we will see a massive change in workforce. We will lose a lot of experience on the shop floor, exactly the things you talked about. How do we capture that experience in a way that we can reuse it? So we bring someone new on board, educate him, give him all the knowledge. It's about knowledge transfer. And knowledge transfer with people is a bit more difficult than with systems. I'm still looking for the USB port.
Right.
And one other thing around that, we've talked a lot about digital twin and building the digital twin. Another thing that I see coming is, and that's going to simplify building the digital twin massively, that in the future you will get digital twins with whatever you're buying.
Yeah.
Yep.
So you buy pieces of equipment, you can see that very clearly at the moment, for example, in mold injection equipment, they have agreed on a standardized description of their equipment. So you buy an equipment, you get the equipment hierarchy, you get the capabilities, everything readily available. So you can use that part and make that digital twin part of your process twin. Combine it with digital twins that you get from others.
Yeah. Yeah. Makes a lot of sense. And not to mention the advent of 3D printing as well, right? I mean,
Yeah.
how
Additive
easy that was.
manufacturing.
Sorry, were you going there, Maximilian? If you want to go, take us there, please.
Until we have blockchain
no.
into it.
Yeah, blockchain too, yeah.
No, exactly. I don't
All the catch terms today, folks.
Exactly. I was staying away from the catch terms and catchphrases. So want to bring it back up a level, if I may. So I completely agree with the human capital aspect, but I think it goes to the notion which I think established at the beginning, which is that ultimately it's about a digital transformation. It's not just the technical use or the technical definition of a digital twin, and the handling of everything that's associated with this, whether it's driven towards performance improvement within an enterprise, or whether it's driven towards creating new offerings, will change how people interact with that, will change the business systems, will actually change the complexion of some of the people we need, right? We have, it's not just a data science issue, right? We need more data scientists, but you need data operators. You need people who can embed and interpret and contextualize the data, right? And so a lot of things will change. So just more granularity to the argument that was made.
Great, thank you. Thank you, everybody. I think we will be wrapping up to kind of summarize key messages.
Yeah.
It's about transformation. It's not about technology. It's about the business outcomes. You can get started. There are many things that will make it easier. And we do want to show you one last slide.
That's right.
On Monday, before the event started, we ran a masterclass on digital twins. And we had 4 competing teams that had 1 hour to build a concept of a very real business problem and solve the problem via digital twins. So this is our winning twin. This is our winning twin.
We created winning twins of all of these people. They're walking around. There's 2 of them.
Yes, exactly. Brett, do you want to comment a little bit? Because you were particularly keen on this use case. Just 1 second.
I was. This team came up with a use case for using a twin in a rail context, but not just to look at the maintenance needs of the locomotive or the train, but to actually use it to sense the condition of the tracks. And I was impressed with it because this was a group of people who didn't come from that industry, and it's an actual use case that we have put into practice to use the sensors on the rolling stock and the trains to actually sense the condition of the tracks, find out how the track conditions contribute to the maintenance needs. So I thought that was a really impressive thing for a team who had no experience in that to come up with that.
I recall you asked them that several times. Are you sure you're not in the train industry? Yes. And I think to that point in summation, right? I mean, the whole notion of ROI. They touched on something that was very specific, very actionable. Start quickly, right? Fail fast. Collect the data, aggregate it, make sense of it, put it into a data lake, and then start creating the actual twin itself. It was a phenomenal model from kind of end to end.
Yeah, and I think the thing that we looked for in the winning team was it wasn't just about the technology or even the cool use case, but it was about the outcome.
Yes.
Tying it back to the business outcome. I think that's what really differentiates a digital twin from just a model of a system.
Yeah.
Yeah, thank you.
Well, with that, I mean, we really want to interact with you guys too. I know it's getting late in the day. It's been a busy couple of days for everyone, but I believe we do have some microphones. Please step up to them. Questions, comments, concerns, or disagreements with the definitions or statements you've heard today. Anyone? Please, yes, please. If you don't mind just approaching the microphone, that should be hot.
Good afternoon. First of all, thank you very much. Great session. My name is Adriana. Nice to meet you.
Nice to meet you.
I would like to ask you if you have any experience with a construction business, this kind of a commissioned business where you have to build like huge pipelines, many kilometers, and if you have a delay in any of this construction, you're gonna lose millions for your customer. Did you have any experience with that?
Yeah, I mean, at Hitachi we have a lot of experience in the construction industry, and it's, the delays, it's modeling out that economic system of the large capital project, as I'm sure you know, and the impact of the equipment breakdowns on the project, and then how to recover from those types of projects. So we've seen it also in mining as a similar sort of situation, where you're really trying to get from pit to port, or from where you're extracting the material out to, and you have a number of different types of machines that then take the aggregate, bring it onto a truck that maybe loads it to a train, that loads it to a boat or something. And anywhere that you have a maintenance issue along that continuum can throw the operation, and that's millions of dollars of downtime. So yeah, I think, and the digital twins actually can be used at the asset level to monitor the individual pieces of equipment to identify what the risk is that they pose to the overall operation, and then at the system level, that network of equipment, to understand the impact of one piece in the overall network, and then try to calculate the risk associated with that, and then you can do risk-adjusted kind of maintenance procedures to the equipment.
And I know I'm just the humble moderator, but I would add that another interesting one that we did is on pipeline monitoring. So we use drones to monitor hundreds, actually quite thousands of kilometers of pipelines, put together the aggregate images over millions of photos, look at where any possible leaks or cracks or anything wrong with the pipeline could be detected, and then move to remediation from there. Another one that Hanspeter touched on very briefly is JCB, which is a large construction company, backhaulers, excavators, things like that. And taking it to what Mark was speaking to earlier, we got as advanced with them as possible to the point where even an operator, not a field service technician who's highly trained, but an operator who may not know a lot about the machine can use augmented reality to fix problems that occur on the fly. So basically holding up a smart device, because we had such a good twin of the devices themselves. So they could hold up an AR interface, a smart device, see what needed replacing, and then pull out something to replace it and fix it. Very cool. Oh, please, Maximilian.
Yeah.
I was getting to the same.
Oh, similar, yeah.
Okay.
We work a lot together. Oh, yeah, we're almost
So,
at time.
so then, can I offer a thought? So you're talking about a massively complex system, right? And I think one thing that Mark said earlier, I think is very relevant in that context, which is, I think the agility of building the system, right, can be driven heuristically, not algorithmically. So because you will understand almost intuitively where the major breakpoints are, right? And you can start building the digital twin around these initial breakpoints, right? And you can expand from there. One of the major complications that you have is that you stand in front of this massive system and try to algorithmically virtualize it, which is really what the digital twin would be, right? I think it's critical, and I think the point was very well made earlier, right? That you crystallize quickly where the starting point is, and then go into implementation there, and almost in concentric circles, build it out over time.
Yeah, and in a real example of digital business models, insurance companies are looking at, the pipeline's a good example, underwriting risk of pipeline operators who implement these types of systems differently because it significantly alters the risk profile of that operation. So we're starting to see some interest from the insurance companies to understand how this technology can help them underwrite that risk differently.
And we apologize. We have a very educated panel,
passionate.
clearly. We're passionate, so we only could take one
could
question.
talk
I
for
think
hours.
we're about there, yeah.
Yes.
Yeah, yeah.
Yes. So thank you so much. We could stick around and answer your questions offline. I think we need to get off the stage. Yeah, the red thing is blinking. So thank you. Thank you for coming.
Thank you to our esteemed panelists as well.